Question 19. X into r minus 7 plus 3 is equal to 19x plus 25, and the equation r is a positive integer. If the given equation has exactly one solution, what cannot be the value of r? R here is not equal to what? Cannot means r is not equal to something. So here we can consider or recall the three cases of the linear equation. We have three cases in the linear equation when it comes to the number of solutions. If the equation is written like this, a1x plus b1 is equal to a2x plus b2. Let's consider the equation is written like this. We have three cases. The first case is when a1 is equal to b1 and a1 is equal to a2 and b1 is equal to b2. In this case, we have infinitely many solutions. Second case, when a1 is equal to a2, but b1 is not equal to b2. In this case, we have no solutions. And the third case is when a1 is not equal to a2. In this case, we have one solution. So we are talking about exactly one solution, which makes this situation ours here. So we are looking at the equation when a1 is not equal to a2. What is a1 and what is a2? a1 is the coefficient of x in the left side. a2 is the coefficient of x in the right side. So in the left side, we have a coefficient of this. So r minus 7 is the coefficient of x in the left side. Must not be equal to a2. a2 is the coefficient of x in the right side, which is 19. And now we can just move the 7 to the other side. R is not equal to 19 plus 7, which is 26. So r cannot be equal to 26, which is our answer. How can we display this on Desmos? We can graph it on Desmos, but we consider the left side because we have a letter like r. We cannot write them all. We have to write this as y equals something and this as y equal. So we can consider two equations here and display them as lines. So y equals to x into r minus 7, and then get outside and write plus 3. That's our equation. Second line. We write y again equals to 19x plus 25. We cannot see the lines here because, or you can see the lines, but this is random. These are random lines because we do not know the value of r. The question says which cannot be the value of r. Anything can be replaced with r except one number. How can we know that number? We can use the slider. I mean, because numbers are from 3 to 26, so we can start from 0, for example, to 27. Let's check them all. Look at what happens to the graphs. R equals to 1. Now we have one solution. Look, this is one solution. Yeah, so everything is okay. We need to search for something that cannot be the value of r. So if you move like this until here, this is where the lines have no solutions. When r is equal to 26. When r is equal to 26, I know that this is not that easy to discover, but you can just check the numbers. You can replace r with the number 3. We have one solution. One solution, which is here. The question says, which cannot be the answer. So 3 is an answer. What about 7? We can replace r by 7. Also, we get one solution here. If you replace r with 22, we can get one solution, but this may be away from here. And if you just move down, you can find the solution here. But if you replace r by 26, we have no solution. These lines are parallel forever. They cannot intersect, which means that r cannot be 26. Question number 20. A real estate company offers a series of 3 webinars. 2,000 people attended the first webinar. 65% of the people who attended the first webinar attended the second webinar. And 44% of the people who attended both first and the second webinars attended the third webinar. Of those who attended the first but did not attend the second, 31% attended the third webinar. How many people attended both the first and the third but did not attend the second webinar? How can we consider that? How can we think about this equation? We say that we have 2,000 people, and these 2,000 are split into two parts. 65 of them, the 2,000 attended the first one. So the first webinar has 2,000 people. 65% of them attended the first webinar, also attended the second webinar. So we are talking about the second webinar. We have 65% of these. How can we get 65%? We can just write 65 and then shift with this sign right here, gets percent times 2,000, which gives 1,300. So 1,300 people attended the first and the second. And the rest of them, which is the remaining, this is why we have to read the whole equation, because the question says of those who attended the first but did not attend the second. So we are looking for these people. We can just subtract 2,000 minus this answer. We can just write 2,000 on the calculator minus answer, which is 700. So we have 700 did not attend the third one. Sorry, the second one. So the second one, we have 1,300 only. This did not attend. And the question says here, and 44% of the people who attended both the first and second, which is this, 44% of them attended the third one. So the third, we have 44% of this. So we can write 44% times 1,300, and we get 572 here attended the third one. But we are not looking for these, because the question says of those who attended the first but did not attend the second, which are looking for 700. 700 people, what happens to them? 31% of them attended the third. Now we have 31% of this 700. So we can write here 31% times 700. These are the people who attended the third one. So 217 attended the third but did not attend the second. Remember, attended the second, only these. This 700 did not attend the second, but this 217 people attended the third and, of course, the first. So we're looking for the people who attended both the first and the third without attending the second, which means 217 is our answer. We can also express this on Desmos by writing the 2,000 as the initial value. And we need to consider also this math in order to see which one to proceed for, to work for. We are looking for the 700, and we get the 31% of these. So we can say that we have 2,000, and we get 65% of them out. We're not talking about these. We are talking about the 700 who did not attend the second one, which is the remaining of this 65%. So we can say that we have 2,000 multiplied by 1 minus 65%, which is the remaining 1 minus 65%. Just write percent, or just write over 100. And then we get 700. Then this 700, we need to get the 31% of them. So 31%, just write percent like this, P-E-R-C-E-N-T. Once you write T, it's written like this for you. Just write 700, and you get the answer of 217. This is our answer. Question number 21. In the xy plane, circle M is the graph of equation here, where A is a positive constant. Circle V, another circle, is obtained by shifting circle M 12 units to the right. Which equation represents the circle? Whenever you have a circle and you move to the right, we need to consider writing minus inside the equation. I mean, when the equation is x plus 6a all squared plus y minus 38a squared is equal to 36a squared. squared. We have to look at this as 36a squared. We have to look at the movement of right. And when I say right, 12a units to the right, it means you come to this one and you add negative 12a. Right inside that circle is negative and left is positive. Also the same as up and down. So we can just write the equation of v again like this. X plus 6a minus 12a means minus 6a. 6 minus 12 is negative 6. So minus 6a all squared plus y, the same. We cannot change anything about y because moving right or left is only the concern of x. So minus 38a all squared is equal to 36a squared. So this is our equation, which is here letter D. And the last question is 22. Here we have some kind of dot plot. The dot plot shows the distribution of capacity for a set of capacitors, set A, which a researcher used for a certain experiment. For another experiment, the researcher used a different set of capacitors. Set B, this is set A. Set B has the same number of capacitors as set A, but capacity of each capacitor of set B is 14 microfarads greater than the capacity of each the respective capacitor in set A. I mean, every number of these should be adding 14 to them. So instead of this 4, this will be 4 plus 14, and so on. So that the other set, which is set B, should be like this. This is 4, so add 14 to this. So 4 plus 14 is 18. And instead of 7 plus 14, 21, and so on. But the same number of points. These are 4, this will be also 4. This is 6, this will be also 6, and so on. And the question says here, which of the following is true about the capacities of the capacitors in set B? What about the information we can get from here? The main capacity is 10 and the range is 12. The mean is 10 and the range is 12. In B, this is not correct because the mean is the number that comes in the middle. So here the mean is what? If you look at this and you see the similarity, you look at the similarity here. What do I mean by similarity? I mean, when you have this dot plot and you have the number of points in the right and the left, they are the same. This is symmetrical. And here also symmetry. So now this is the mean. So the mean is 10, but for the set of A. What happens to set of B? These numbers are changed. 4 becomes 18, 7 becomes 21. We add 14. Every time we add 14, so this 10 becomes 24, this 13 becomes 27, and this 16 becomes 30. So here we have the same number of points. So the mean is still in the middle, but the middle here is 24. So the mean of B is equal to 24. And then, so this option is not correct. It says the mean is 10 and the range is 12. We'll talk about the range later. So the mean of capacity is 10. They are talking about B. B is not 10, so we also cancel B. The mean capacity is 24, that's correct. And the range is 12. How can we get the range? The range is just subtracting the greatest number minus the smaller number. So 30 minus 80, which is equal to 12, which is, by the way, the same range of this. So 16 minus 4 is 12. This is also the same difference. So 12 is the answer of the range. And the mean is 24, which is our answer, letter C. Why not D? The mean is 24, yeah, but the range is 26. From where did we get the 26? 26 is not correct. The range is the last, or let's say the greatest minus the least. 30 minus 18, which should be 12.